everyone, and welcome to today's webinar on Autodesk iLogic and Configurator 360. Just before we get started, I just want to do an audio check with people. So if someone can just type into the chat that's on the bottom of the screen, or the bottom of the control panel on GoToWebinar, if they can hear me okay, that'd be excellent. So I'm just doing an audio check. So if someone could just type into the chat on the bottom of the screen for a quick audio check, and then we'll be able to begin the presentation on Autodesk iLogic and Configurator 360. Okay, cool. Thanks very much, guys. I got an okay on the audio there. So to get started, welcome again to today's webcast on enhancing productivity with Autodesk Inventor using iLogic, and also an overview of Configurator 360. What we'll do is we'll just give a brief introduction, first of all, to myself and also to people who aren't aware of A2K Technologies. So my name is Niall Smyth. I'm a consulting technical lead with A2K Technologies. My background's in mechanical design, and I've been using design tools like Inventor for nearly 10 to 12 years. A2K Technologies were the largest Autodesk reseller in Australia and New Zealand. We've got over 150 staff across Australia and New Zealand, which means we've got the technical support to give you the best advice on how to use the products. Most of our technical staff come from industry, so we can relate to the type of designs that you're working on. Okay, so what we'll do is we'll start off with an introduction to iLogic and solid body modeling, and that'll be the live demo part. So I'll just give people an understanding of what iLogic is, and also we'll show people what solid body modeling and how that can be used to accelerate designs. I'm also going to show people how to use Excel to drive iLogic assemblies, and to read parameters from Excel, and also to write outputs from Excel. So that way you can get salespeople to fill in order forms using Excel, and also can generate materials lists or quotations automatically as well. The next thing we'll cover is an introduction to Configurator 360. And when we're doing that, we'll talk about ways that the design process can be automated, and also ways you can increase the design part of that process. So there's been studies carried out in terms of what defines high-performing manufacturers, and I'm sure that's what everyone who's logged in today and watching this webcast wants to find out. How to increase their productivity, increase their efficiency, and increase their effectiveness. So the study carried out was called Best Practices for Developing Industrial Equipment, and it was carried out by Tech Clarity. And the findings showed that the people who are at their top of the class, or top of their game, they've got 2.2 times revenue growth in comparison to the average. And they're also making 2.4 times as much profit margin in terms of their growth. So the question is, how can we learn from this study? And how can we replicate what these top-performing companies and top-performing manufacturers are doing, so we can also get the same benefits? So the way that top-performing manufacturing companies attain these types of figures are through automating processes. So at the bottom of the pyramid, we'll see that the average companies tend to just stick with 2D design and engineering. And as you move closer towards those top-performing companies, you've moved into 3D design engineering. So that's the 3D modeling, which is a huge step up in productivity. Creates many opportunities for using the model downstream, like simulation and rendering. So if you're on two-dimensional drafting, you simply can't do some of those things. So 3D level is better, and it's kind of a prerequisite almost to effective modular platform design. So you can see that the top performing companies, they're really focused on design automation first of all, And the real best in class then are focused on sales automation, where they've automated everything from taking the order, clarifying the product, creating the configure design, creating a drawing, and then outputting a quote, or sorry, an invoice at the end of the process. So there's different ways we can do design automation with Autodesk tools. So the concept of design automation has been around for quite a few years, and you may already be doing some of it to a certain degree. You may have created custom programming based on AutoCAD, or if you're using Inventor, you could have used iParts, iAssemblies, which are table-driven designs. If you're using Inventor with iLogic already, then that means you're getting into the world of rules-based design for design automation. And then ETO, which stands for Inventor Engineer to Order, that takes it to the next level with more advanced automation capabilities and also integration with business systems such as ERP. But regardless of the technology and the processes, design automation is all about streamlining and improving the engineering process for configured products. That means the manual effort is reduced, tedious tasks are taken out of the process, and also accuracy is improved because all the design is based on design rules. The ideal state that most manufacturers want to get to is about 80% of the business coming from configured products where engineering and sales is mostly automated. That means it frees up engineering to focus on innovation and higher margin projects. And that's the 20% that truly require custom designs and engineering and that can yield much higher profits. So design automation is a building block, and it's essentially a prerequisite for sales automation. But before we start talking a bit too much about sales automation, engineer to order, and Configurator 360, what we'll do is we'll jump into Inventor, and we'll just give a look at what iLogic is and how people can get started on using iLogic. So inside an Inventor, what I'm going to do is just create a very simple example, and I'm going to keep it simple so we can focus on the iLogic part as opposed to the application. So what I'm going to create is a simple rod in a plate, and we're just going to make it, as we go, we're going to name our parameters. So I'm going to call this parameter ROD for rod outer diameter, and I'm going to make it equal to 50 mil. And what that does is it gives us a parameter that we can use in our parameters table. So you can see your model parameters when we go to the FX symbol on our quick access toolbar. Gives us the parameter we have just put in. So if I right-click on the sketch and I say dimension display and I change it to expression, it shows me what the name of that parameter is. So we can change that again back to just its value. And if you can't see that menu when you right-click, just press escape on the keyboard because it's most likely you're either right-clicking on a line, which gives a different right-click menu, or you've got another menu selected as well. Okay, so that's one part of our initial assembly that we're going to work with, and we're going to use solid body modeling as well. So solid body modeling is essentially creating multiple parts within one part file. So what I'm doing is, as I'm creating a center point rectangle, I'm going to type in the name of the parameters. So width equals, let's say maybe 400, and I'm going to press tab on the keyboard, and I'm going to say height equals, we'll just, instead of making it a separate parameter, we'll just list it like that, and we'll put in a dimension, and we'll set them equal to each other. It'll just make it a bit simpler as we go along. Okay, so we've got our rod OD that's going to fit in through this plate. So we also need to put in a hole ID. So again, the exact same thing. What I'll do is I'll draw in a circle, we'll dimension it, and we'll name the parameter as we go. So, and I'm just seeing some questions coming in. And okay, so what we'll do is we'll leave the questions and answers until the end of the webcast, and we'll go through them in detail then. Okay, so as we're putting in the outer diameter, so I guess it would be the inner diameter for our hole. What I'll do is call this hole ID, and we'll set that equal to maybe 52 mil. So we've got a 2 mil gap there for clearance. So with our very simplified sketch, let's extrude and create these solid bodies. So to create a solid body, when we see the extrusion tab pop up, there's a little button here that I'm just highlighting. And that's to turn our extrusion into a solid body. So when I press that, I can create another parameter again, and I can say length equals maybe 300. And you can see that I've created an extrusion that's 300 mil length. What I want to do is use the exact same sketch. So in a way, what we're doing is like a master sketching technique or a top-down design technique. So by making that sketch visible, I can reuse the same sketch. And again, we'll just create a thickness of the plate here, so maybe make it 15 mil. And again, we press the same button to make a new solid. And what's actually happening when we do that is when we go to the left-hand side, we can see a folder called Solid Bodies in our browser tree. And we've got Solid 1 and Solid 2. And we can rename those solids as we go if we like. And as we rename them, we can call this perhaps rod and this plate. Okay, so a very simple assembly or a very simple part file with two solid bodies. If we want to convert this into an assembly, what we would do is we go to our Manage tab and we click on Make Components. It's just telling us we need to save it. So I'll just leave it as Part 1 is fine. And we select the solid bodies that we want to work with. Okay, and then it creates an assembly in our standard assembly template file, and it tells us where we want to save. So we'll say, do we want to create a new target assembly? We'll say yes, and we'll put it into our iLogic webcast. And again, we'll just leave it at the default name for demonstration purposes. Okay, so again, it allows us select our template, which I need to update my styles on, and now we've got an assembly file. So if we go back to our part file, what we want to do is we want to program in some intelligence into our part file, which will then flow through to our assembly file. So the way we do that is using iLogic. So let's say we've got 3 different designs for this particular assembly. So we want to create variants A, B, and C perhaps. So what we do is we go to our parameters table and we add in a text parameter, and we can call this maybe model. And what we'll do is we'll make this parameter a multi-value parameter by right-clicking and selecting multi-value. And we'll add in the parameters A, B, and C. So let's say for model A, we've got a particular hole clearance. For model B, we have a particular hole clearance. And for model C, there's a different design again. And because there's a nonlinear relationship between the variance of the rod outer diameter and the plate inner diameter, we want to specify exactly what the dimensions are for each of these cases. We also want to maybe, for model C, we want to put a fillet onto the outside edges of our plate. And we also want to notify the user that they need to consult with engineering if they're selecting model C. Okay, so at the moment we've got a user parameter ABC, but the actual switch or the parameter as we change it doesn't do anything. So to link up some intelligence to that parameter, what we do is we go to our Manage tab and we go to our iLogic panel and we add a rule. So we'll call this rule iLogic plate model selection. Okay, and what you'll see when you go into the iLogic browser is on the left-hand side we've got a lot of system snippets. What that is, it's like predefined sections of code. So for example, if I wanted to turn on and off a component, I'd go to the components node on the tree, double-click on component is active, and I could put in the name of the component, and then I could set that to equals true or false, based on if I want to turn it on or off. Okay, so on the model or the window in the middle, we can get access to our model parameters or our user parameters, so everything we've designed our model with. We can also see our extrusions. So let's give it a quick test. So we want to build in an if-then, end-if statement. So we've got some nice little syntaxes in here in our drop-down menu. Got some keywords next to that for doing case select statements, which are a bit more advanced. And we've got access to some operators as well. So even if you haven't done programming or coding, it's quite easy to find your way around and make sense of the iLogic browser. So what we want to do is we want to go to our user parameters, and we want to say to Inventor that if our model parameter, and we can access our model parameter by double-clicking on it, and we can say if model equals, and what we'll do is we'll put in the letter A, and we'll put inverted commas around it because it's a text or a string. And we're saying if model A, then do a certain range of motion or range of operation. So what we'll say is let's go to our model parameters, and we'll say that maybe for model A, we'll leave our whole ID as 52. We'll also change or leave our rod OD as the value it is at the moment, which is 50. So we'll have a 2 mil clearance. And we'll leave our length of our rod at 300 mil. So this is our default setting. So we're saying if the user parameter equals A, then whole ID equals 52, the rod outer diameter equals 50, and the length equals 300. So that's fine for one scenario. The way we create a second scenario is, again, we go to our if-then, else-if statements. So we say else-if, and we can use some copying and pasting here. So I'll just copy and paste down our next parameter, saying if model equals B. Then we'll change our parameters to a different set. And we'll say maybe our whole ID for model B needs to be 50 with the outer diameter set to 55, and the length changes to 250. Then we can create another else-if statement as well. Again, we'll copy this down. And we'll say else-if model equals C. We'll change maybe the whole ID to 54. And we'll create a bigger clearance here. So we'll make that 59. And we'll say the length goes to 200. Okay, so we're basically telling Inventor that if the model, our user parameter called model equals A, then we want these criteria. Else if it equals B, we want these criteria. Else if it equals C, then we want these criteria. So it's always a good idea to, after writing a little piece of code, to test the model or flex it. So we'll click OK, and no errors have kicked up. So what we'll do is we'll turn off the visibility of this sketch as well, just to make it a little bit easier to see. And we'll go to our parameter table. So we'll change it to model A. And that should be our default. So we'll go to model B, and we can see our model has changed. And we'll also go to model C, and we can see it's changed again. Okay, so let's just see if my sketch is named correctly. So we've got model A, B, and C. Okay, so we've definitely got things changing. I may have named my parameters slightly different, I think. So, or maybe my iLogic rules didn't allow for clearance. So I've got rod OD equals 50. Here we go. So make this 45. So the OD is smaller than my whole ID. And here we go again. So let's test that again, and we'll update, and we should see clearance between our rod and our plate. So our rule is working okay. We can see it changing, and diameter is changing as we change our user parameters. Okay, so the second thing we wanted to do was for model C, we wanted to put on a warning. such that the user needs to consult engineering because this particular model can only be used in some applications. So for this, we can do a message box show. Go to our message box snippet, double-click show, and we can put on here saying, for this model, please consult engineering. And we can put on a title, just attention. And what we could also do is, let's put in a fillet for Model C as well. So to put in a feature, or change a feature, what we can do is in our model, we'll put on our fillet using the fillet tool, and we'll make the radius quite big so we can notice it. And we'll just fill it on the 4 corners. Okay, so we've got an extrusion created. And we can see that it's extrusion 2. So the way we put this on in our iLogic code is we go to Model C again. So first of all, we've got a message box showing up saying, for this model, please consult engineering. And we also want to have the fillet turned on for Model C. So we can right-click on fillet, open the middle browser window, click Capture Current State. And what that gives us is the information about that feature. So we can see the name is fillet 1, the feature is active, and the radius of the fillet is 50 millimeters. So we're not going to change the radius of the fillet, so we can take that out, and we also don't need the name of the fillet. So we can just say feature is active equals true for Model C, and we'll turn it off then for Models B and A. So we'll just Control C and change it to false, and false again. So if we click OK on that again, we'll test our rule as we go. We'll click on our parameters and we can see, okay, we've changed it to Model C. Our warning has come up, please consult engineering, so that works okay. B, there's no fillet, so that's working okay. And A, there's no fillet again. Okay, so hopefully you get the idea of a brief introduction to iLogic and what it can do. So our next goal or task is, what I'll do is I'll show you a pre-prepared model, just to give you an idea of what you can do further with iLogic. So we can close that again, and as you can see here with our assembly file, as I update that, it'll reflect back on what the part file has been modified to. So just to show you that again, we'll go to part 1. With solid body modeling, as I change my part file settings, let's change it to C. Okay, and done. And we go back to our assembly file, we hit update, and that updates our assembly. So using iLogic and solid body modeling, it's a very efficient way because you don't have to go passing part rules into assembly rules and so on. You can just put all your intelligence into the part file, which keeps it simple, and then any changes flow upwards to the assembly. So what we'll do is we'll give a look at a model that I've pre-prepared. And let's say this is a scenario where we build racking systems. And with this racking system, what we want to do is we want to have sales guys open up an Excel spreadsheet, punch in the dimensions that they've got the order for, so that when I come into Inventor, I can just put in the order number. It changes to what the dimensions the sales guys have put in. And I also want it to write out automatically to another Excel file, so I can give it to my purchasing officer to order the material for this particular design. And as well as that, I want to do a little bit of drawing automation in that I want my sheet size to be changed to a particular size depending on the rack dimensions I choose. And doing all that eliminates a huge amount of lead time when a customer gives me an order. So what we'll do is we'll go to the folder where I have all of these files. And you'll see in this folder I've got a material order report folder and also an order form folder. So with my order form, the sales guy will come along. He'll take the last order, the rack order 4568, and he'll right-click and go copy. or he or she will, and we'll paste a copy of it. Then we'll change the name of the file to the next number in our ordering system, which is 4569. And then we'll open up that Excel file. And we can see here that we've got certain parameters that we can control. So the overall height of the frame, the last one was 1400, so maybe we want to change this to 1500. We want to put in perhaps 4 bays. And our section size, we offer some standard section sizes, so we'll go for a heavier duty section. We'll go 70 by 70 and a wall thickness of 5 mil. So we'll leave 3 levels, or maybe you want to put in just 2 levels. We're going for heavy duty, big components. And then they press save on the Excel file. So the designer then comes along, and inside in Inventor, I have all these rules set up to just run automatically once the designer hits save. So there's a warning coming up saying that sizes smaller than this require engineering sign-off. So a nice warning. We click OK to that. And the model should update in accordance with the settings that we've punched into our Excel file. So what I'll do is I'll just go back to the Excel file and we'll change it to a height between 1500 and 3500, and we'll say, right, let's go 4000. And the number of bays, let's just change that again to 2. Number of levels, 2, and we'll go with the heavy duty wall thickness, so we'll hit save. And we'll go back and then we'll hit save here again to fire off our rules. Okay, so I'm missing a step in my process. So it's actually reading the old order form number, and that's why I'm getting that error consistently. So what we can do is, once the designer opens the part, we can have this form automatically pop up. And this form, as you can see, is a picture of our racking system. And what we can enter here is our order number and our material order number. So let's do our order number first of all, and we'll say, right, the next consecutive order was 4569. So once we click done, that'll tell Inventor to look at the correct assembly file. And again, we've got a warning saying that size larger than this require engineering sign-off. So we'll click OK, and our model updates on our racking system. So if the order were to change, again, we'll say, let's say 3000, go for middle of the road. We'll say the maximum number of bays, let's put in 3. And we'll leave the section size heavy, and we'll put in an extra level. So there's a live link maintained between the Excel file and Inventor. And again, if I hit save, it'll update that file, and our design changes. Okay, so let's say that's one step of the process. It's been automated. We've got our design configured the way we want it to be configured. The next step would be outputting that to a material order number. So again, we could do the exact same thing that we did for the initial order number by just copying an Excel file, renaming it, and then punching in the material order number. So with our existing material order number as 1234, we could say done, and we could go to our material order report folder, and we can see it's 1234. Again, if we were to change that, we could copy it and paste it, and that way then we're maintaining our records, and we can just go 1235. And then back in Inventor, we tell it which file to write to. Instead of 1234, we go to 1235, click done. And again, we'll hit save just to run those rules automatically. And when we go to our material order number, we can double click here. And it tells us the section length we've picked, which was the heavy duty 70 by 70 by 5, the length of the sections, and also the quantities. So as well as that, I've put in a costing. So you could generate automatic quotes from this type of procedure. And what we'll do is we'll jump back into Inventor and we'll just look at the codes that made this possible. So in terms of our iLogic rules, we saw some warnings pop up there. we've got some assembly rules here, and basically that's what we've talked about earlier on, in that if you're working with assemblies and parts, then you need to pass through certain parameters from the part up to the assembly parameters, which I've got here. So all these parameters in blue are user parameters that exist in the assembly. And all these other parameters on the left-hand side are parameters that existed in the part. So for example, if we go to one of the parts, and we go to the user parameters, we can see that these parameters here are from the solid body master part, bay width, and so on and so forth. So that's a very simple rule. The next one is limits of our design. So these are what we demonstrated earlier on. So if the frame height is a certain size, then show a message box. If it's a frame height greater than a certain size, then show another message box. So again, we've covered the basics of that. The rules that call up reading Excel. So this is the rule that we can read our order report from. So what I've done here is I've just simply created a variable within the rule called Excel file. And I've set an Excel file variable is essentially like a bucket or a placeholder. And it's just holding this address here. And that'll allow me then, say, when I want to reference this address, instead of having to type in the entire address, I just type in Excel file. So it's a little bit of just making the design code nice and tidy. So I'm telling Inventor that my Excel file lives in this certain location. And what it's doing is it's appending on an iProperties value, or a custom iProperty, which is called order number. And then the extension .xlsx. And we append on parts of the file path using the ampersand symbol. So what that allows us to do is, because we're entering an order number, we can change the Excel file that Inventor is looking at each time. So once we've put in our order number as it's correct in our custom iProperty, which is in our iLogic form as well, we can then say that our frame height parameter is driven by Go Excel, which is basically telling Inventor to start up its Excel tools, and the name and location of the Excel file, the sheet, and the cell. So we're basically reading our parameter frame height from this cell C2 in our Excel file that's listed up here. And where we get these little bits of snippets, so it's not that I'm very good at coding, what I do is I go to my Excel data links up here, and I look down through the list and I figure out which one I want. And as I hover over each snippet, it gives me a little tooltip. So the tooltip here is that it reads or writes to a cell. So if I were to recreate that line, I'd say, yes, that's exactly what I want. I want to read from a cell. So I'd double click on that. And you can see here that it gives me Go Excel, that cell value, file name, sheet, A2. So it gives me all this syntax here. And then all I had to do was pick the parameter that I wanted to work with. So frame height in this case, and I just set it equals to. Go Excel and put in the name of the Excel file and its location, and sheet and cell number. So what I want to do then is specify the rest of the parameters, and because I've told Inventor where the Excel file lives already, I don't need to use the cell value in that long format each time. What I can do is call cell value current, and that gives me Go Excel value to the Excel file that's already in the rule. And that would then I can link the other parameters to the other cells within the Excel file. So I'll delete that bit and cancel out of that. I would say no. And before I close that, you can see also just at the end here, we've got an update document. So what that does is it just basically updates the Inventor document once these rules have run. And that makes sure I don't have to keep pressing the lightning symbol up on top. And again, that's in our document snippet over here. And it's document update. Okay, so we'll cancel out of that. And we'll say save changes to rule. Nope. And the way I've worked the costing in this particular assembly, We double click on it. I've created a custom iProperty called cost. And what I've done here is I've just put in a round iProperties, a rounding function, which looks at the iProperties of the mass and multiplies it by a certain value. So if I know the cost of steel per kilo, then I can get a costing estimate. Or if I knew it was cost per meter, then again I could measure the certain parameters and put them into my costing columns. So if I were to recreate that particular rule, the way I would have done it was, again, creating a custom iProperty first of all. Then I would have said, let's go to our iProperties node up here. I would say custom. Again, gives me the snippet. Punch in the name of my custom iProperty, press equals, and what I wanted here to do was round the number. So I didn't want, because the mass of the mass property in our iProperties goes to 3 or 4 decimal places, I really wanted to go to the nearest dollar. So there's some functions in here called math, I think. Yep, and we can round up or round down. So this one here, round the number to the closest integer. So I would have said yes, round. And the number I want to round is, again, my iProperties mass. So I go to my iProperties node on the left-hand side, find the mass property, double-click on it, and I can delete the variable that I don't need, iProperties.mass, and then I can multiply it by whatever I like, and just close our bracket again. And again, delete any unused text. And that's how I've created the costing of my assembly. Okay, so again, we'll click OK to that. And the last one is Write Excel. So again, we'll just give a look at this one. And it's very similar to the Read Excel functionality. So again, we'd use our Excel data links. First of all, creating a variable, telling Inventor where that Excel file lives. And we used the exact same functionality as we did for the order form. We put in our iProperties custom value, and we created a custom iProperty called material order, which we then put into our iLogic form. So users can punch in a material order number, and then we can look at the particular file. And this time what we're doing, instead of reading or writing, instead of reading, we are writing. So this time we put Go Excel value first. So we go to the Excel value, and then we set that value in our Excel equal to, or we drive our parameters from that Excel value. So it goes to the Excel sheet, looks at it, and then makes the parameter that we named equal to the Excel value. Or sorry, the other way around, excuse me, I've got that backwards. So it looks at the model, looks at the frame width parameter, and then puts that into cell E3. Again, cell E4, and puts our parameter bay width into cell E5. And that allows us then generate things like our section width, section length, wall thickness, length, and our costing that's down here. So in terms of our quantity, the way I've worked this, you can see when I click on our quantity, what I've done is it's actually referencing another Excel file within my folder space. So inside my folder, I've got another Excel file called BOM353, and that's a folder that's just basic, or a file that's being updated by Inventor, and it's updating it with its bill of materials information. So after I've put in all the values that I want on my Excel file, I've put in another rule down here called thisBOM, or a bit of code called thisBOM.export, parts only. Name the file whatever you like, and then tell it what format you want. So again, this little bit of code is located in our BOM section. Double-click on export, and again, it gives me a whole lot of comments for the different file formats that I use. So I can see here that I want Microsoft Excel, so I copied and paste Microsoft Excel format up here. Get rid of the section of the text that I don't need, and name it what I like and what particular parts of the bill of materials I want. So that was the easiest way I could see of doing that. And at the very end then I've got goexcel.save, which is from my Excel data links. So it saves the Excel file once it's updated this. So that's very simple and not too complicated. So we'll close that and we'll say no again. And the last step in our iLogic demonstration is to modify our drawing slightly. So let's go to our drawing. And again, you can see that it's referencing views from my model. But I've got some rules in here again once I hit save, that it should resize the sheet and reposition the views within the drawing. So you can see there it's repositioned the views and it's changed the actual sheet size. So our sheet size was A2. And we've got things like our order number reference here, our cost and our material order number in our title block. So again, we're trying to automate as much as possible. And let's say the rule I've set up when we look at this is that if a particular parameter in our assembly is less than or equal to 3, then we use the A3 sheet size. And if it's greater than 3, then we use the A2 sheet size. So we could test that. Let's go back and change our number of bays from greater than 3 to less than 3 and see if our sheet size updates. And again, we've just got a document update here as well. And we can click OK to that. So let's just give that another quick test. And we'll go to our designs again, iLogic Webcast. And we'll change our order form slightly. Oops, just need to escape out of that one and close it. Okay, so let's change our number of bays to 2. Overall height, let's change it down to 1500. We can leave our heavy-duty sections on there. Or we can change them if we like. And number of levels, let's just change that to 2 as well. Okay, let's save that. Let's go to our Inventor file. And let's go to assembly. Let's just hit save so it runs our rules. We can see our assembly changes. Okay, so it's asking me, do I want to replace it? I'll say no. I'll just say OK to that. That's just because my files are already open. So what I'll do is I'll just cancel those a second. I would redo it. And I'll just close down my material order number. So I'll just save that as we go. And again, we can leave those as is. The model has updated. And we'll just hit save again. That'll run our material order number. So our correct quantities and costings go out to our Excel file. So when we go to our drawing, we can see the views have updated, but our sheets have not changed size. So again, once I hit save, you can see that our sheet changes back down to an A3 size as we wanted it to do. Our order number is still referenced with a different cost and so on. And we're trying to automate as much of this design creation as possible. So hopefully that's illustrated the way you can actually automate things like the product configuration, writing out to material order numbers or generating quotes, and also generating your drawing. So just to show you the view positioning bit of code, again, it's saying that if a parameter is equal to a certain value, then I want to set my spacing to the corner to 50 by 30. So these are my XY coordinates here. And I can change these XY coordinates as I go. And all of these codes are in here on our drawing node. So, and again, what we can do is just to show you that I'm not actually typing all these in bit by bit. What I do is I just click on our maybe view from corner or view set center. And we can set the view, once we know the name of it, set it to a certain value. We can set our view heights. Oops. Let's go down here and show you the kind of things we can set. We can set view heights or read them, view scales, view from corner, and so on. So it is pretty self-explanatory, and you will find your way around it after a few goes. Okay, so that's an overview of iLogic. I hope you've had time to take that in, and if you want, our webcasts are posted up on our website, so you can go back and you can pause it, copy the bits of code that I used and learn from it. So let's go back to our PowerPoint presentation. And let's just finish up by talking a bit more about design and sales automation. So typically, if we were using our shelving system that we looked at there, the first stage would be requirements capture. So we'd have to talk to the customer, tell them find out what they need. Then we'd have to go back and configure our product if it was doing a manual process. After that, then we'd have to look at our costing, our pricing, and our timing, and then put forward a proposal, a completion, and finalization documents. So the sections in green are what are our sales efforts, and our section in red is what our engineering effort is. So you can see how iLogic really configured our product, but we also leaned into the requirements capture stage as well, and also some of the costing, pricing, and timing, and some of the proposal completion things. So iLogic is very powerful that way. You can do a lot of stuff with it. And if we're not using iLogic or no form of automation, you can see that the issues we'd have at the requirements capture stage would be that we're taking longer to quote. We're potentially quoting inaccurately because we're not referencing a set of design rules that we've already approved and checked. And there's also lack of transparency. It means we can't show the client a general assembly drawing very fast. With the product configuration, that can be a long lead time because sales guys need to get in contact with designers and so on. There can be delays there. There can be miscommunications. Cost estimations, again, there's a risk of quoting inaccurately. And then finally, the proposal development. You can't actually put in an accurate general assembly drawing into your proposal because it's not created, because it takes too long to generate it. So with design and sales automation, the idea is that the product configuration is the longest part of the process. It's where design, engineering, and automation can be streamlined a lot using iLogic. And that's really a kind of prerequisite, as I said, a prerequisite for sales automation. So for sales automation, we've got two options inside in the Autodesk set of tools. One is Autodesk Inventor that we saw, which is iLogic, and the other is Engineer to Order. So Engineer to Order is a much larger solution, much more consulting required to set it up, whereas iLogic can be set up by the designer. In terms of sales automation, there's two options as well. One is the Engineer to Order. Again, that's a big enterprise solution that can be customized and linked in with business systems. But there's also Autodesk Configurator 360. And this is an excellent product that I think once people are aware of, they'll start adopting more and more. And what it does is, again, we're focusing on the top part of that pyramid. It allows us win business more profitably. So we're not going to look really at Inventor, Engineer to Order today. We're going to focus on Autodesk Configurator 360. And that shows us that it's an online application. And what it does is it allows us, it's a cloud-based solution. And it's essentially the fastest and easiest way to provide engineers, sales, customers with web and mobile access to your product configurations. So for most people, this is going to be the best way to start realizing the benefits of sales automation. So let's just move on and look at that in a bit more detail. So as I mentioned, it's a cloud-based 3D product configurator for Autodesk Inventor designs. There's no download or no installations on your computer. It's all online. You just upload your Inventor files. So that means you embed 3D configurations directly. You can embed them directly into your existing website. And you can automatically provide configured models, drawings, images, price quotes, and enables custom product manufacturers to publish designs to an easily accessible cloud environment. So let's give a look at it in a second, and you'll see that you get results in minutes, not months. So it's a very easy, quick thing to set up. It's available for free trial on the Autodesk website. So if you go to Google and type in Autodesk Configurator 360, you can get a 30-day trial, and you can really have a play with it. And what it does is it recognizes parameters that have been listed in Inventor, either using iLogic or iAssemblies or iParts, and it generates that online model for your clients to use. So as I mentioned, it's very simple. You just upload your Inventor designs. You can upload assemblies, parts, and drawings. And you can control then what the end user can configure and download. So you can allow them to download, say, SAT or step files if you want of your model. And that way then they can build their designs around your existing model. And the fact is that if they've started using your design early in their design phase, they're most likely to purchase it at the end. It also has the functionality where you can get an iPad app with it. So you can build and customize your own iPad app with your catalog of products. And from a sales point of view, that really makes communication very easy. And it shows a very impressive side to your business in that you can on the fly configure and change things, get a quote done, and show them exactly what they want. And it's that visual communication of saying, yes, it's this particular width, height, branding, and different fittings on it, as opposed to just looking at a table in the catalog. So the whole point, as we said, is to win more business profitably. And the Configurator 360 is a very low-cost way of doing that. And it offers 2D drawings to your clients, quotes to your clients. And there's also a feature in there where they can request a quote, where it will send an email to the design team or the sales team, and they can get back to the client straight away. So the way it works is, with your catalog of products that you upload, you can copy a link for a particular product. Then you can email that link to a prospect or your sales team. They can click on the link and it will bring them to the products that you forwarded to them. And we'll just look at it here. Once they access the website or the link that you've forwarded to them, they can go in and view the model, rotate it around, zoom in, zoom out. And on the left-hand side, then you can see they can change the configuration of the product. So it can update as we change, or we can postpone the update till the end. And again, the length and types of duty of the trailer that we want, whether there's a jockey wheel on there and so on, and then we can update it. And this is a recording, so I've cut out some of the wait times. And then you can see the configuration of the trailer that you want to, or the client wants to purchase. And the outputs on the right-hand side, we can access PDF files, so we can automate the drawing process again for general assemblies. So straight away they can get a PDF of the general assembly drawings. You can also download it as FAT files or step files, as I said. And here's it's taken it a step further as well, where you can actually get a quotation out from the configuration selected. And you can see that there's a request a quote button as well. When we go back on the bottom right-hand side of the screen, you've got a request a quote button, which pops up a little form that the user can fill in, and that can be sent to your sales department or your engineering department or whoever needs to see it, and they can be contacted straight away to finalize any questions and answers they have. So again, you can see that you can very quickly and easily, configure a product online from your existing catalog. So here's just a snapshot of the catalog that's available online as a sample demo set. And you can have many products up there. You can have your own branding on there. You can have your own branding colors to make the website truly a company website. Okay, so I'm hoping that that has been a good presentation and introduction to Configurator 360. And what we'll do is we'll allow time for some questions and answers. And what I'll do is, if you've got any questions and answers, just type them into the question dialog box on our GoToMeeting, and we'll work through them as they pop up. Okay, so that seems to be pretty good. There's no questions popping up. So thank you very much for your time, everyone. I appreciate you taking time on your busy day to log in. And hopefully this has made a lot of sense and you get some value out of the presentation. And until next time, we'll see you at the next webcast. Okay, take care. Bye.